Let's look at some harder ratios to simplify from the 7th grade material. These are similar to ones that you would find in chapter 6 and would be helpful for your study guide for the chapter 6 test. All right, let's go ahead and look at this one. The first one that I want to do is 7.5 to 12.5. All right, so when we're looking at this one, can we change it to a fraction? Can we change them to fractions? Yes, we can. I'm going to show you two different ways to solve this, and you decide which one is easier for you. All right, so first things first, when I'm working with decimals with ratios, I have the option to change them into fractions. So if I rewrite 7.5 as a fraction, it would be 7 wholes and 1/2. And if I rewrite 12.5, it would be 12 wholes and 1/2. All right. So at this point, we know that we can't really do anything with this until we have changed it. Changed it. It would be nice if I wrote 1/2. Change them to have the same denominator. And we are quite lucky, now that I've fixed my mistake, that they have the same denominator already. All right. Our next step would be to change them to improper fractions so that we can actually do something with them. So in order to do that, I know that we multiply our denominator times our whole, and we add that answer to our numerator, and then we drag our denominator down. So I'll start with the 2. 2 times 7 is 14. 14 plus 1 is 15. And I know that it's over 2 because the number of pieces in my whole did not change. Here we go again. Multiply 24, add 25, and then drag our denominator. All right, the next part here is to get rid of the denominator. To get rid of our denominator, we have to multiply both sides by 2. And let me show you why we can do that. We're going to multiply by 2 on both sides. So let's look at 15 for a minute. Let's solve it the way that it is. So we're going to say 2 times 15. Well, what is 2 times 15? 2 times 15 is 30. Now we need to divide by 2. 30 divided by 2. Well, what is 30 divided by 2? It's 15. By adding that multiply by 2, you are basically canceling out your denominator and you're left with only your numerator. Let's see if that works the same way with your 25 over here. So I'm going to solve your numerator first. 25 times 2 is 50. Now I can divide by 2. 50 divided by 2 is 25. This works when you multiply that common denominator by both sides. I want you to listen to that. You have to have a common denominator to make this work. So if you have not found common denominators, meaning they have the same exact denominator for both fractions, then we cannot do this. We had a 2 on the bottom of both of them, so we were able to multiply by 2 on both sides. Your ratios have to stay balanced. They have to be equivalent. So if you multiply by 2 on the left-hand side, you have to multiply by 2 on the right-hand side as well. Now, we're left with 15 to 25, which we can go ahead and simplify that. And I know that 5 will go into both of these. So 15 divided by 5 is going to be 3, and 25 divided by 5 is going to be 5. Your simplified fraction is 3 to 5. Simplified ratio, is 3 to 5. Now, let me show you another way to solve this that could be easier for you. When we divide a number by a decimal, we have to move the decimal. For instance, If we had 130 and we were dividing it by 6.5, we would have to move this decimal. In order to move that decimal, what you're doing is you're multiplying by 10. You're getting rid of the decimal so that you can work with whole numbers. That's the same thing that we are going to do here. I want to get rid of that decimal, so I'm going to multiply both sides by 10. Wait, why can I do that? Because if I'm doing it to both of them, the left-hand side and the right-hand side, then they're going to stay equivalent. So I'm going to multiply by 10 on both accounts. All right? So quick math, this is going to be 75, and the right side will be 125. I know that because anytime I multiply a decimal by 10, my decimal moves one place value to the right. If I multiplied by 100, it would move two place values to the right, and so on. So my new ratio is 75 to 25. So I'm thinking of the greatest common factor I can think of is 25, and I'm thinking I'm going to divide by 25 on both sides. Why? Because I need to keep them balanced and equivalent. 75 divided by 25 is 3, and 125 divided by 25 is 5. I know that because if I count by quarters, 25, 50, 75, 100, 125, I could end up with 5 quarters before I got to $1.25. Still 3 to 5. There we go. So remember, we can multiply by a number like 10 or 100, depending on where our decimal is, to give us whole numbers in our ratios. Okay, let's look at another one. Let's do 0.64 to 2/5. This one is a little bit different because we are working with a decimal and we're working with a fraction. So the first thing that I want to do is I'm going to go ahead and try to get to whole numbers as best I can. And to do that, I'm actually going to start with my decimal side. So I know that if I multiply 0.64 by 100, then my decimal point will move 2 times to the right. Once would be 6.4, twice would be 64. Now, remember, if I multiply on the left-hand side by 100, I have to multiply by 100 on the right-hand side. 100 as a whole number, it's just 100. 100 as a fraction, it's going to be 100 over 1. So when I multiply across. 200 times 100 is 200. Multiply the bottoms. 5 times 1, 5. All right, step 1. Look for whole numbers. Are we finished? No. We have a whole number on the left. We do not have a whole number on the right yet. However, if I divide this improper fraction of 200 over 5, I will end up with 40. So I'm going to rewrite this now. I've simplified my fraction. First thing I did was I multiplied my decimal to get the whole number of 64. After multiplying my decimal, I simplified my fraction, and I'm left with 64 to 40. Could I have changed my fraction to a decimal and then multiplied both of them, both the left-hand side and the right-hand side? Definitely. This is just the method I chose. I chose to work with my decimal before I worked with my fraction. So I'm at 64 to 40. I need to find the greatest common factor. And in this case, it's going to be 8. I'm going to divide both sides by 8. Divided by 8, divided by 8. 64 divided by 8 is 8. And 40 divided by 8 is 5. Your simplified ratio is 8 to 5. So, review. We changed our Well, we created whole numbers. That means multiplying your decimals to move your decimal point, and then simplifying your fraction on the right-hand side, which is what we did. So we're going to say simplify. And then step 3 was to divide both sides of your ratio by the greatest common factor. If you didn't want to do the greatest common factor, you could have divided here by 2. And then you could have divided by 2 again, and again, and again, as many times as you needed to, because they're both even, to get to the simplest fraction. You don't just have to divide by your greatest common factor, but if you do know the greatest common factor, it saves you from having to divide multiple times. Last one. Let's look here at 8/9 to 16/27. All right, so typically we would say turn them into whole numbers. This isn't really an option yet because we have fractions. Okay, so now what do we typically do with fractions that don't have the same denominator? Well, we try to find the same denominator. Remember, our goal here is to get to whole numbers, and in order to get to whole numbers, they can't be fractions. We need to get rid of our denominators. So, in order to get rid of our denominator, we have to have the same exact denominator. And I don't. So, I'm going to compare my two denominators, see if one of those denominators can turn into the other one. And in fact, we can. 27 is larger than 9, so I'm going to look at 9 and say, can I change a 9 into a 27? Well, I'm going to count by 9s. 9, 18, 27, look at that. It's easy. I was able to count by 9s 3 times to get to 27. So I'm going to change my fraction on the left to be something over 27. I know that it's going to be something over 27 because I just decided I needed a common denominator, and that 9 was indeed a factor of 27. So I can turn 9 into 27 by multiplying by 3. So 3 times 9 for my denominator is 27. 3 times 8 is going to be 24. Rewrite. I've rewritten my left-hand side. I'm going to rewrite my right-hand side. 16 over 27. Now remember, we are going to try to get rid of that denominator. So we're going to multiply the numerators of both sides by the denominator. We're multiplying by 27. What are you left with? You are left with 24 on the left, and you are left with 16 on the right. So now we can reduce, we can simplify by our greatest common factor. Say, for instance, I don't know what that is. I'm going to go ahead and I'm going to choose 2 because I know that they're both even. 24 divided by 2 is 12. 16 divided by 2 is 8. Still not reduced all the way. Is there a number that goes into both of them? Yes, I could do 2 again. 12 divided by 2 is 6. 8 divided by 2 is 4. They're still not reduced as much as possible. Please watch. I'm rewriting this up here. Now I'm going from 6 to 4. I'm going to reduce. Again, they're both even. I'm going to reduce by 2. 6 divided by 2 is 3. And 4 divided by 2 is 2. Final answer, as low as it'll go, is 3, 2, 2. So what we did on this one, we found common denominators, canceled your denominators by multiplying that common denominator by on both sides, and then reduced or simplified our fraction. Ratio, excuse me.